Hello everyone, my name is Ryan Schewel. Welcome to my channel. So in the lesson today, in the video today, I want to show you how you can merge a bunch of flat files together and load each one into separate and distinct tables in SQL Server. So I actually had the job back in 2019 to 2020. 2020 COVID hit and everything was shut down. Everybody lost their jobs like that. Blink of an eye, everybody was gone. They said, "You're fired, you get out of here." But the project was mostly successful up to the point of COVID hitting, and basically we had to take about 1 million, I think it was 1,100,000 separate and distinct files, identify each one, see what the contents of the file were, and and load each one into separate SQL Server tables. So we took about 1.1 million files. We ended up with about 255 or 260 different tables. And the whole task was to identify the files that were mostly substantially similar and merge those together. And if it was somewhat different, then you had to put those into different tables, right? Because these files were different. And the craziest thing was it came from a very reputable, very, I would say, very mature data provider. The catch was you can't just take everything and concatenate everything under the like new files under old files, or what's it called? In SQL, it's called union. In the Python world, it's called concatenate, where you take, like, let's say files from January, February, March, April, May, June, and July, and the whole year, and take this whole time series data and concatenate everything underneath each other. So you have a big stack like a Pringles. If you imagine like a Pringles can of chips, one chip would be 1 month, and another chip would be another month, and another chip would be another month. And you see this all the time, right? I worked on Wall Street for 22 years. A lot of times people will take everything and you'll have this time series of data. So you'll have this month and this year and this month and this year, and everything is basically standardized and uniform. But this would have different fields and different headers and different column names as time went on. So it's very hard to get everything to say, okay, well, in January, February, March, you have these columns. Then in April, they introduced a brand new column. So you have to anticipate that, and you have to build that into your model, and you have a new column in April. But then in May, it dropped off again. And for the rest of the year, it was missing. Then in January of the next year, then you had a couple new columns that came back, or one column that came back and a couple new columns that just appeared out of nowhere. Like, how can you anticipate this unless you take a mapping of every single file, 1.1 million files in this data lake, and then try to aggregate everything and anticipate, okay, new headers are coming in, new columns are being introduced. Then sometimes they fall off, and then sometimes they come back, and then, they're gone, and then they come back again. Like, that was a crazy thing. And this is a big name. I won't name any names. I've never named any single company that I've ever worked for or clients I've worked with on this channel. But like, you would think this would be somewhat standardized. Okay, so you could just do the load. That was absolutely impossible. This data was so crazy. It was impossible to do that, right? So we spent months and months trying to figure this out. As soon as I joined, 2 of the lead data scientists working on the project got fired. So I was immediately promoted to the lead data scientist. I've been there for 1 week. Now I'm leading the whole team after 1 week. Very, very Wild West, very like just quick, reactionary. You have to learn, you have to figure these things out, right? So I put together some code and I got it done. I did the whole lift. I did most of this work myself. I'll show you what I came up with right here. So basically, this is the ask. Crawl through all the files, all the folders, all the subfolders. And you had subfolders for months and years, going back in time for years and years. Evaluate all the files, all the subfolders, all the hierarchy, all the structure of everything. We had to auto-harmonize similar column names. So if you have things like account ID and account ID, that could actually be the same thing. They changed the names of these things and they changed it back. And I made calls to the people that sold us the data, or actually rented the data. We had to rent this data to do this analysis. And we had to like delete everything after it was all done. I don't think I've seen that before, but that was the scenario that we're working with. So we rented the data, and they would have account ID and then account underscore ID and things like this. So we had to look for similar column names that weren't the same. Again, you can't just concatenate everything. That would be too easy. You can't union everything. That would just be too easy, right? They had to make it very challenging. Merge everything into one data frame, and then take the data frame and push it into a SQL Server table. So again, the whole stuff that we had to deal with was evaluating 1.1 million files, see what's substantially similar, merge that into a one data frame, push that into SQL Server, right? Evaluate all the files, go through this iterative process where we're using fuzzy matching, right? Or rapid fuzz if you need like a more accurate kind of like matching, like kind of sharper results. There's a couple ways to do this. Merging everything from the 1.1 million files into about 260 tables in SQL Server. So let me show you what I came up with. I think that's enough backdrop there, or preamble, whatever you want to call it. So I'm going to go ahead and create some synthetic data. We had bond data, equity data, options data that we're trying to merge together. So this is what the data looks like. I have some bond data here, right? If you're a fixed income expert, you're going to understand this. If you're not, then you're going to learn. You're going to learn very quickly. You learn on the fly. So we have some identifiers right here: the company, issue date, issue time, bond ratings, the currency that the bond is issued in, and so on and so forth. I'm going to create a data frame. Okay. So the goal here is to take and paste this into an Excel file or into Excel and save this as a CSV file. Everything came as a CSV. Now, it doesn't matter what the type of the data is. So you could have CSVs, you could have text files, Excel files. I hope you don't have Excel. Excel is a wonderful tool in many cases. If you're a data scientist or a machine learning engineer or even like a software engineer, you probably hate Excel. And you know what I'm talking about if you fall into one of those groups. But we can put it into a CSV text file, Parquet file. This can be JSON, XML. It could be in another database. If it's already structured, that's fine. The whole challenge was it was sitting in a data lake, which is basically just a computer desktop. It's a big folder that's essentially your desktop. And you can take everything and anything in the world and just dump it in there, copy and paste, right? So I created this data frame. This is what I start with. We have an index because we're dealing with Python here. We can delete the index for our purposes. In the CSV file, I'm going to go ahead and create and save this. I'm not actually going to save it. I'm just showing you what to do here. I'm showing you the steps here. So save to this PC. You know, I will just save it to my desktop, but I'll delete it immediately. So take a quick coffee break here. This is bond data. I'm going to put CSV over here. I like MS-DOS. That one's good for me. And bond, as in James Bond. Save it to the desktop. Okay, so now we have the CSV file. So that's how the data comes to us, right? In this job that I had, this crazy job that I had. So there's the CSV. We had 1.1 million of these things. So we had to take all of this data and consume it. Here's the equity side over here. So if I can hit Control Enter, I can create the synthetic equity data. I'm going to take it and copy and paste it into another CSV. And then I have my options data down here. I'm going to create that into a CSV. Again, just synthetically creating data and like hypothetically imagine how we can create 1.1 million files. We rented this data from a very reputable source. Again, no explanation why the column names were changing, why you couldn't just load the data. Nobody could do this. Nobody understood it. And then we had some real estate data on top of it, right? So here's some real estate data. If I hit Control Enter in my cell here, and I'll share all this code with you guys, right? I'm going to give you all the code. And here's the real estate data. Did I misspell that? ESTA. There's always little issues here, and I'm constantly debugging data. Okay. So that's fine. So all the files are saved and created. 1.1 million. You can imagine the effort that goes into that, the labor, all the stuff that goes into that. So this is just a very small sample. Here's what we come up with. Here's bonds, equities, options. Okay. And that is for February 2024. Just making up some random dates here, guys. You can imagine how this works in the real world here. I have about 10 files here, but you can imagine 1.1 million right? It gets to be quite a bit. And if you open this file right here, good time for a coffee break. You see what this looks like, right? And it's going to basically represent exactly what we saw over here, right? If I go back to real estate data, we have address, city, state, ending in listing, sales date, and status, right? So on and so forth. Just to give you the backdrop and the backstory on this thing right here. All right, so that's what it looks like. So let me close that. So 1.1 million files, right? Mostly the equities are mostly equities. Again, changing column names. I don't know why they did this. Nobody could explain it. After multiple phone calls, I just gave up. Fixed income is basically fixed income. Again, it would change. Adding new column names, dropping the column names, sometimes adding brand new column names, sometimes after the column was dropped off after a year, it came back again. I don't know how they would load this in the real world. Like if you're getting all this different data, how can you load this? You would have to hire hundreds of people to groom through the data and comb through this and like validate and create all these things. I don't get it. I don't know who's doing these things, but I had to come up with a solution for this whole thing, right? So I put all the files into this folder right here. This is called My Files. This is the hierarchy of files. So if you look closely, it's called My Files. You see the dates over here. If I go back right here, if it's sort of the parent directory, this is where everything sits. Enter, enter. Okay, here we go. So February, January, March, imagine years and years and years worth of stuff for every month and all kinds of different files. This is only like a very tiny subset. This is not even like a fraction of 1% of the things I had to deal with, right? And again, 2 of the key people were fired 1 week after I started, so I had to level up very quick and just take care of the stuff basically by myself. We had a project manager, we had a DBA, we had a what was that guy? Like an architect. We had a cloud architect that we worked with, right? But nobody's gonna get this stuff, right? So I had to figure it out by myself. So this is what I came up with. We're gonna go ahead and loop through all the files in the folder, create a list of files. This is going to be called results. So Control F, results. We have the file path. File path comes from here. Control F. If I look for this, file path is here. And we use this technique called OS walk. So this is operating system.walk. So we're walking through or stepping through all the files in this folder, looking for all the directory names, all the subdirectories, right? All of the folders and subfolders, and what's the file name? What's the file look like? What are the contents of each file, right? And load all of this into a memory, into a data frame. So basically, I can visually inspect this and just get like a what's it called? Common sense or what is that? I forgot the term. Just like common sense. Critical search, common sense, confidence check, or build up some kind of confidence. I just want some parameters to operate within, like some guardrails, right? So a sanity check. That's what I'm thinking about. A quick sanity check, just to say, does the file look good? Okay, what's the contents of the file? What do the column names look like? I just want like a quick visual sanity check of these files. So if I go through and run this right now, Control Enter, I'm going to share all this code with you guys, and you have the code above to build this. So I'm not going to share the files. Sometimes I share the files with you guys. I'm not going to share the files because you can build it yourself, right? So here's the real estate data. Here is the option data. Okay, here's the equity data. Equities are stocks, right? Like Microsoft, Amazon, what else? Facebook, all these stocks. And here's a fixed income, right? So fixed income comes from a government issue, municipality, right? Sometimes from corporate issues, sometimes preferred. You have preferred issues. I always thought that was funny. I got my MBA in finance. I had a teacher that always says, do you want standard or you want preferred? Preferred sounds better. It just sounds better. It's no different. You have like a little bit different rating on the thing. It's no different, but a lot of people like preferred. Preferred just sounds better than standard, right? So you have these different fixed income instruments that are issued. So you have the data, right? So you can go ahead, copy, paste that into some CSV files, load that into the same file structure that you see here, and just put this into different folders. So this is what mine looks like. I have my files right here, and I have 3 different months. So February, January, March, Okay, if you look in each one, this one happens to have 4. I'm trying to represent the differences of these files. This one has 3. January has 3. And February has 3, right? So we introduced one new file in March. That's exactly what happened. We had these new files come out. And these 3 files in these 3 folders, we have 4 in March, but the 3 files in January and February are just slightly different, again, to represent the differences that would come in. I don't know why they can't make it the same. No idea. You can't just load the data. That's impossible to do it, right? You have to analyze and bisect and parsect and all these different things, right? So that's the task right here, right? So we're going through Control Enter to run the cell. So we have the file path, just because, again, I want a sanity check. I want to know where these files are coming from, right? I don't just want to load the data, boom, done, loaded, and my boss comes up to me and says, well, how do we know that we captured everything? And I will come back and say, well, I don't know. And how do we know that it's been validated? And I said, I don't know. And and then he says, well, how have we reconciled the data? I said, I don't know. You can't say, I don't know, right? Like, you have to have some kind of validation, some kind of sanity check, some kind of like system where you literally say, this is the source of the file, right? And we have bonds. We have bonds here, right? This is February, this is January, this is March, right? We have bond data. Here's February, January, March, and we have equity data, right? Equities is right there. Then we have February, January, March, and then March again. And we have options, CSV, options, CSV, options, CSV, right, for the 3 months. And then real estate CSV. Remember, in March, we introduced a new file, right? So if my boss comes up and says, well, how do we do the sanity check? How do we validate? How do we cross-reference or reconcile? This is how you do it. You have the file path, you have the file name, and then you have the columns, right? So ISIN, this is an identifier for a bond, right? Ticker, that's a symbol for an equity, like Apple, AAPL, Microsoft, MSFT, Starbucks, SBUX. This is an identifier for a bond. ISIN, I forgot what it stands for. Let me look this up. ISIN identifier. International Security Identification Number. Okay, so it's just what it sounds like. International Security identifier. Then you have so you have the company name, right? You have the underlying price. You have the city, state, sector. So you have this information in these column names, right? And this helps you identify, okay, what's been loaded. I know it's been loaded. Like, these files have been loaded into the data frame. We have February, January, March, and this is the file name, right? So I have the path of the file name, and then all the column names in each file, or they're called features. And in the machine learning world, this is called features, or data science are called features, right? So you can just visually check this pretty easy. Okay, what's been loaded? I know what's been loaded. What has been identified? I know what's been identified. What has been reconciled? I haven't done it yet, but we're going to do that in just a minute. And then we have like confidence, right? We have some system here that's kind of mature. We kind of know what's going on. We kind of can understand if a business analyst comes up to me, says, well, what's been done so far? I can check the boxes. Okay, we've done this. If a project manager comes up and says, oh, can you help me understand, what's the status of this? Okay, we've consumed the data, we've loaded the data, we know what the data is, we've accounted for things, we've reconciled things, right? Like, I could give them a status update. So that's what this step is for, right? So now I want to take everything from the data frame. And again, guys, just keep an open mind here. Real life, 1.1 million files. Here we just have 10 files, right? And 3 different folders. But in reality, I don't think you're loading 10 files if you're on a project that's going haywire and just totally sideways and everything is wackadoodle. Nobody really understands what's happening. You talk to the big business managers that set this whole thing up, they don't even understand what's happening, right? I had to figure this out all by myself. I had no backup, I had no support. I can't just reach out. I tried to reach out to people, the people don't even respond, right? So I had to figure this out for myself. So everything now has to be loaded into a structured database. So we have 1.1 million files scattered all over this data lake. I have to take everything, reconcile it, consume it, load it into a structured database, right? So this was called SQL Synapse. I think that's a great name. I don't know who came up with that. Kind of funny, kind of mysterious, like a synapse. What's a synapse? Sounds kind of cool. It sounds a little bit wild and a little bit like a little bit disturbing at the same time, but mostly cool, I guess. SQL Synapse, basically SQL Server sitting on Azure, right? So everything goes into the cloud in a structured format. The structure is SQL Server. So you have the name of the database. The name of the server comes first. So this is my device. The name of the database is here. And all you need is this code. Again, I'm going to share all the code with you so you have everything you need. If I open my instance of SQL Server, you can see exactly the same thing. So my device is the server name, right? If I expand this, you can see here all the databases listed here. I have two databases. I have a test database and AdventureWorks LT. This is the light version of AdventureWorks. Microsoft gives you this for free. I have another video where I kind of explore AdventureWorks and I take you through that, and you can see the different parts of AdventureWorks. So basically, comes in as just a practice database. You can practice with your SQL. I don't think I need that. Practice with your SQL and how do you join together different tables? How do you make queries? How do you selects and aggregation and transposing data and taking it and manipulating, doing ETL things, right? So here's the different tables and AdventureWorks. We're not talking about that. We're talking about test today. So here's my test database. I have a couple of tables I created, just doing silly little things in my channel or just testing a couple ideas. Cash flow, I have my new table, right? So some basic things like that. So I'm going to take everything from the server. Here's the name of the server. There's the name of the database. This is pretty much standard SQL right here. Trusted connection equals true. Now, if you're working in an environment that's Azure, you would need security login credentials. You can Google that. It's very easy to set up. You would have to put in your username and password to have access to the server, right? You need IAM, Identity Access Management, and very easy to set up. You would change the code a little bit. So your code might be slightly different, but be almost exactly the same as this, right? So I'm going to start with the table prefix. As I go and scan through all the files on my desktop, again, this is the root directory right here, right? Imagine 1.1 million files sitting here. I'm looking for minimum fuzziness of 0.82. So the fuzziness of the column names I'm looking for has to match that. If you look closely right here, here's bond data, bond, and bond, right? This is February, January, March. So these names match. ISIN, issuer coupon, issuer date. We can go to the right. Price, currency, volume, these all match, covered. Oh, so this is different, right? So this is where the differences come in. This is why you can't just load the data. That would be way too easy. We can do a concatenation or a union, right? This whole thing would be done in a day. You can't do that. You have to look at the closeness of the names of these columns. If they're mostly close, then load all those together, right? Like, again, for the life of me, I don't know why they're changing column names, but that's what they did, right? So these names are exactly the same. If you look over here, duration, rating, currency, volume, exactly the same. I can load that. Updated rating, then this says unnamed, right? So there's not even a name for that column. And then you have updated rating again. So these I know are the same. This one, I don't know what this is, right? But I have to get this data into the same place as the other data so everything aligns, right? So if I'm looking at bond prices or bond ratings or bond issuers, these are going to be the same, right? When I get into SQL, I want to query that. I don't want to worry about, well, sometimes it's bond issuer, sometimes it's company name, and then sometimes it's stock ticker. Like, this is not going to work, right? Your analysis is going to fall down in less than a second. It's not going to work. You have to structure these things so the columns are the same in SQL Server, right? So everything is structured, organized horizontally, right? Those are the columns, vertically are the rows. That's how you have to get it in that structure. Right now, this is the end of the fixed income, but the equity stuff continues down here. So we have beta, dividend, EPS, PE, ROA, ROE. So these are the same. Then you have risk when you get to equities, right? If I go to the left, you'll see the equity data right here. All right, so that matches that, that matches that, that matches that. So we're fine there. And we have ROA, ROE, ROA, ROE. Then we have none over here, none over here. Then we have risk that just shows up all of a sudden, right? It didn't exist before. And then we have none and none. So the nones we can kind of ignore. We're not too worried about that. It's different data. Then we have the option data, right? Then we have the real estate data that shows up in March, and that's totally different. So we have option, 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 bid, ask, last spread, mid. So this stuff is mostly the same. Over here, we have recommended, recommended. and then none, and then none, and then risk. So we have to count for these things, right? Everything has to be structured in the same way, in the same format. So that's what this code does. So we're looking at clustering these, right? So we're doing a few things. We're reading the files, right? Reading all the contents, doing a clustering exercise, doing fuzzy matching. So the column names are mostly the same. Those go into the same table, the same column, the same table. If a new column appears, it gets appended over to the right, right? So we're creating new columns. If they just show up all of a sudden, hey, this new guy is showing up. Let's get him organized, get him into the next, because we have to analyze that data. But if it doesn't exist, it doesn't exist. There's nothing that we can do about that. If it exists, we capture it. If it doesn't exist, it doesn't exist, right? So we're doing clustering and merging of data, right? Concatenation is stacking everything like in the Pringles box. You're stacking everything vertically, or union. In SQL, it's called union or concatenation. Merging is when you take everything, if it exists, you align it right with the same column, same name, merge those together underneath the same column, right? Almost like a concatenation or a union. But if it's different, append it over to the right, right? We're not going to drop those. We want to capture it. But if it's there, we capture it. If it's not, there's nothing to do, right? We can't capture it. So we want to use PyODBC. This is Python, Open Database Connectivity. This is the server name. This is the database name. This is standard. This will not change for you, okay? It's going to be exactly the same if you have a trusted connection. If you don't, just use your credentials, okay? Google that. You can figure that out. So we want to read all the CSVs. So that's what this user-defined function does. We read the CSVs. We want to normalize everything. So if it's uppercase, make it uppercase. If it's lowercase, make everything lowercase. We want to standardize and group everything together just to make everything uniform and standardized. That's the whole point here, right? We want to take everything that honestly could take maybe a year for several people to go through all these files, analyze it. What is this file? What is this file? What is this file? What is this file? You'd have a lot of business analysts or a lot of like data analysts like looking at all these files, right? 1.1 million files, and come back with a report. It's going to be very manual, time consuming. People inevitably will make mistakes. You're going to have a lot of mistakes in the data. Things won't sync up, they won't align, and it's just going to be a jumbled mess, right? We want to eliminate all these problems and take 1 year, what a task that could take 1 year, and do everything in 1 day. That's the whole thing, right? So we're trying to do 1 year's worth of work in 1 day. So 1.1 million files loaded into the structured SQL Server database called Synapse. I like the name, so we're creating this user-defined function. We're normalizing the data. We're building a canonical map, and anything that could be named a little bit different but have minimum similarity greater than 0.82. So this is an arbitrary cutoff. If it wasn't obvious, it should be kind of obvious. Anything greater than 0.882, and this could change for you. You could say 0.86, 0.89, 0.79, right? It's up to you. Like, how comfortable are you with these similarities? Because you could potentially get data that should go into one table, but the file names or the column names are very different, and it could actually go into a different table. So that's kind of a different problem. I didn't encounter that. I didn't have these kind of issues because I did a lot of preparation and a lot of work up front to try to prevent that from happening. You could have a little bit of data that's mislabeled or goes into the wrong place. You just have to deal with that on a case-by-case basis. But I think 0.82 is a good minimum threshold for cutoff. If it's mostly similar, it's going to go to the same table, right? So you could set this at 0.95 if you want to be very confident, but then you could drop things and you'd have data that should be in one table that actually gets merged into a different table. So that's kind of a different problem that you have to deal with, right? You have to kind of like figure that out. And you might have to do this a couple of times, go through some iterations and see what works for you and what doesn't work. So anyways, we have the business logic set here. We're going to go ahead and loop through these CSV files right here, right? Build a whole system. The whole hierarchy is derived based on these logic points right here, and everything is going to be loaded into SQL Server, right? So if we take a look at the SQL Server tables right now, I have a couple of tables here: employees, cart, cash flow, my new table, post-purchase, salaries, and users. Okay, so I'm going to go ahead and run code. I set this up yesterday, tested it in the afternoon. Everything ran fine. I'm going to share this code with you. I'm going to give you everything you need, right? This is called Jaccard similarity. So this is an algorithm that was set up to look at similarities between different column names. If it's mostly similar, it goes into the same table. If it's mostly different, it goes into a separate, distinct table, and we're going to see what the results are. And we're doing some clustering too, right? To get these clusters set up and aligned so it's close enough to go ahead and say this cluster is cluster A, this is cluster B, this is C, and this is D, and then push all of that into SQL Server. So when I run this, you can see what the results are. We have a printout over here. Python 0 base, so we always start with 0. This is really 1, 2, 3, 4. We have 4 different files. Remember, fixed income, equity, option, and real estate. And you can see merged CSV cluster bonds. These are the equities. These are the options. And this is the real estate over here. If we take a look at SQL Server, you can see what it looks like. Hit refresh over here. Okay, and tables go over here. And magic. Okay, so we have bonds, equities, options, real estate. So these are 4 new tables we just scanned through. Again, 10 different files. You can imagine 1.1 million. This would probably take a day to set up this code, right? And it might take, I'm not even sure how long to run it. 1.1 million files have to be analyzed. Jaccard similarity has to be done. Clustering has to be done. I'll just hazard a guess here, maybe 1 day to run the code, maybe a day to set it up, a day to run it. But in a couple of days, you're done with the whole task, right? Otherwise, you would have to hire, I don't know how many dozens of analysts or business analysts or data analysts or something to go through manually and check each file. Again, I guarantee they're going to make mistakes. Been on Wall Street 22 years. I know how this stuff goes. It's mistakes constantly, all the time. You have a lot of mistakes. This could be a headache. Maybe it'll take you a year. I'm just guessing. I don't know, maybe a year. I would prefer the automated method, right? Data set the code, the day to run the code, and you're done. If we go check SQL Server, we can see what we have here. So cluster bonds, select top 1000. Let's see what we get here. Okay, so executing query, and we have 60 rows. And you can see covered over here as null because there's nothing in here at this point in time. But down here we get the data, right? So if we look in March, we have data. If we go back to January, there's no data, but everything aligns correctly, right? We have coupon rate, coupon type. Is it covered or not covered? I just made that up. I'm not even sure what this is. This is the currency, duration, ISIN, issue date, issuer, maturity, price, rating. Okay, so we have a new column showing up over here. This is null, 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 null. If we go back over here, these are all nulls. You can probably drop this column, or when you're doing your SQL query, when you're doing your analysis, just don't select this, right? We're selecting everything from here. If you don't want the column, just don't select it, right? If you do select all, select, update this, update this, covered. You don't really need those square brackets. It's good practice. Whoops. I didn't want that. I don't want that one, right? Issue date, issuer, maturity date, pricing, updated volume, control. Oh, this is F5. Now I'm in SQL Server F5. Oh, this stupid thing. I have to do the function, I think. Function lock. Now it's going to work, I think. Yeah, F5 to run it. Okay, so covered. Maybe I don't want covered. That's just something I came up with. I don't even know what that even means. F5 to run it. Okay, so now you have your SQL, right? So here's the currency, duration, ISIN, issue date, updated, rating. I just came up with that. It's really nothing. Okay, I just want to change a column name because that's what happened to me. So now you have your SQL data and everything is structured in SQL Server. Here's all your bond data. Let's say you need to look at equities. Select the top 1000 equities. Let's run this. And you can see the 52-week high, low, equity data, everything is structured. We have the risk here. So is null. Our ROE is sometimes null, but sometimes it exists, right? So if it exists, we capture it. If it doesn't exist, we don't capture it. That's it. That's it, guys. Like literally. We have all the PEs, the price, the issue date, the company that issued the bond, and then here's the proof for the business analyst or the project manager, like what was done, what data has been loaded, what's the source, things like that. So we have the file name and the file name is right here and the source path is right there. Let's look at our option data, make sure everything is on the up and up over here. Take a look at this. Okay, so file name, source path, bid, ask price, delta, exchange, open interest. Yep. So all the option stuff looks fine. Vega volume, we have the Greeks over here, strike data type. Okay, so everything looks totally fine. We'll take a look at one more. This was the fourth file. Just showed up in March, right? Didn't exist in February, didn't exist in January. Now in March, all of a sudden we have real estate data. So if we have it, we capture it, expand this, we have all the source paths and the source file name, and then all the data. So for the business analyst or project manager, you might want to show this, right? In reality, this probably won't be part of the analysis. You're probably not analyzing file names. F5 to run, and here's your SQL data. Okay, so you have the address of the property, bathrooms, bedrooms, square footage, sale date, sale price, and whatever you need to include, you include, and if you don't, you don't. So all the magic comes from here, right? So again, I want to beat the dead horse here, but if we go back over here, we created all the data dynamically, and this is synthetic data. It's not real data. I just created it to illustrate the point. These are the bond records over here. This is the equity. Here's the option data over here, and then here's the real estate data. We copy paste that into Microsoft Excel, save it as a CSV file. You load it, right? Checking the file names, checking the file name and the path, just to make sure everything is on the up and up. Make sure you have your quick sanity check over here. Load everything here. This is the server. This is the database name. This is not going to change. Leave that exactly as is. But then, again, if you have to log in, you have login credentials or IAM, Identity Access Management, you will have to update that, right? So that's really up to you how to handle that. You probably will have login credentials if you're working in a public environment, not public, but like in a shared environment. Then you're going to have to log in with your own credentials. You could share credentials. Maybe I've seen that happen. So everything goes in there. You have the merged table prefix, right? And then again, we're doing the Jaccard similarity to look at the similar column names. Once we just clean up a couple little things, make the uppercase, uppercase, lowercase, lowercase. Actually, we're making everything lowercase here. Any kind of zeros or 0 to 9, any kind of numbers are stripped out. Column names really shouldn't have numbers in them. Building the mapping down here and renaming. If the minimum similarity is greater than 0.82, that again is an arbitrary number, but I think it's fine in this case. If these column names are mostly similar, yeah, load that into the same table. That's similar data. If it's mostly different, load that to a different table, right? And we're doing some basic, here's the Jaccard similarity down here, right? So we're looking for all the columns, all the rows, all the records. This is the I and J looping process down here, and then clustering into 4 different clusters. So this was basically set up predetermined because I knew that we had fixed income. I knew that we had equity. I knew that we had options, and I knew that we had real estate data. Your set might be slightly different, but you should have an idea. Like if you have 1.1 million files, I guarantee you're not going to have 1.1 million different tables, right? That's going to be merged together. So you might have to define the number of tables you're going to end up with. Is it going to be 100, 200, 300, 400? I don't know. That's something that you have to determine for that. But you're going to take a lot of stuff, 1.1 million, and aggregate that into a much smaller number, a couple hundred, maybe it's 100, maybe it's 200, maybe 300. That's what you have to determine, right? Run the process. You get your quick printout down here. This is going to be just a quick sanity check to say, okay, everything is loaded. And that's it, guys. So we took all the clustering, right? Harmonized the data based on Jaccard similarity, based on clustering techniques, merged everything from 1.1 million files into 260 different tables. In this case, we came up with 4, right? Just trying to streamline the whole process. But that's it. I'm going to share all the code with you. Save this right now. I will save this file down, and I will share the code with you. I post a video a little bit later today. And again, keep an open mind about this, right? So if you are a new data scientist and you join a team and nobody knows how to do this, you can say, hey, I saw this video about how to take 1.1 million files and consolidate that into 260 tables, right? Or maybe 260, maybe you just consume that into 260 different data frames and then save each one. Maybe you're saving data frames as CSV files. You're just doing a basic consolidation or a basic aggregation or something like that, right? Just as long as you know the concept and you know how you have something that looks like this is an impossible task. Like, how are we ever going to do this? How are we going to overcome this challenge? How are we going to manage this process, right? Like, how are we going to do this? Now, at least you have a basic idea. This is possible. It's not hard. It's a little bit technical. It does take a little brain power, out of the box thinking, but it's doable. Definitely doable. And it's not that hard, right? Have an optimistic feeling, be proactive, be confident in yourself, right? And say, I don't know like exactly how we're going to execute, but I know it's possible, and I'm going to figure out a way to deliver on this process and this promise, right? People rely on you, right, to be a creative thinker, to be an innovator. Like, innovation is one of my top things. I say to people all the time, I like to innovate, and all the time I get the, like, a deer in the headlights look, like, what's innovation? What's innovation? Innovation? What are you talking about? So there's going to be pushback. There'll be people that are naysayers. There'll be people that will dispute, and they're pessimistic, and they say, you can't do this, all these things. You have to overcome this resistance, right? Overcome the challenges and be better tomorrow than you were yesterday. Be better today than you were yesterday, right? Like, have that optimistic outlook and take that with you, right, on your path to success. So I'm looking at the time now. I just hit 41 minutes. I'm going to wrap it up. I'm going to share all the code with you. You have everything you need to be successful, to map 1.1 million separate and distinct files and a data lake into 260 tables in SQL Server. That's all structured and perfectly organized and harmonized, right? So you have everything you need. That's it, guys. I'm going to wrap it up right here, and I'll see you when I post the next video. Goodbye for now.